Okay, so in today's session, I want to revise the I want to revise just some questions, some past questions. So I hope you can see my screen. You can unmute your mic and respond if you are following. If you have any question, you can unmute your mic and let me know. All right. So this is the first question we're going to attempt here. So I believe that by now we have watched uh, some of the videos that I've already done in the past from the portal. So this is the first question, number one. I hope you guys can see my screen. Can you see my screen? Please unmute your mic and respond if you can see my screen.
Yes.
Yes, we can.
Okay, so can we attempt this question? The question is on the screen. What will be in this box here under exposed and disease of 445 vaccinated children? There were 3 deaths from TB. Then in
Sorry,
523
please.
non-vaccinated,
Good
there were
evening.
18
Please, I can't
deaths.
access. I can't see the screen. I'm not seeing the screen.
Is it too small?
I'm not even seeing anything.
Can anyone see my screen?
Yes, I can see it.
Okay, so the person that cannot see, can you log out and join again?
Okay, that's all right.
Yeah. Okay, so what we put in this column here, based on the question on the screen, what do we put in this column here? Where my cursor is?
3.
3. Okay, let's confirm. Set of 445 children that were vaccinated. So the first question is, what is the exposure, right? So here we can identify the exposure. So the exposure is what? The exposure is what? The exposure is what? Vaccination, right? All right. Okay, so now of 445 vaccinated children, so that tells us that 445 children were vaccinated, right? So that means the total number of people that were exposed, they were 445, right? So we will have our total exposed here as 445. So the total exposed is 445. Okay. The person playing music, can you mute your mic?
Yeah.
So the total exposed is 445.
Clever, give me the remote, please.
Are you guys following me? So the total exposed is 445, right? Then we have, out of these 445 that were vaccinated, there were 3 deaths. Okay. So we have our exposure as vaccination. Then what do we have as our outcome? Our outcome is what? In this question, what is our outcome? Based on the question, what do you think is our outcome? Is it a disease? What is our outcome in this question? We have identified the exposure as vaccination.
Death.
Now we need to identify the outcome. What is the outcome in this question?
Is it death?
Yes, death is the outcome. So death from TB. Okay, so that is the outcome. So this is the first thing you need to do: identify the exposure and then identify the outcome. Right now, it says of 445 vaccinated children. So the word vaccination will tell you that the total vaccinated, the total exposed is 445, and then disease here, that's the outcome, is now deaths. Okay, so 3 deaths occurred. So among these 445 people, we have 3 deaths occurred among these 445 people. All right. So that will leave us with what? 445 minus 3, right? So what is 445 minus 3? What will it give us? 445 minus 3. That will give us 442, right? Please, I will need feedback. If you are following, you can unmute and give me a response. Now, the next question is in 523 non-vaccinated. So if the exposure is vaccination, it means that the non-exposure is what? Non-vaccinated, right? So a total of 523 children. So here will be 523. Okay. So that is the total for the non-exposed. And then among these 523, there were what? 18 there. So you put your 18 here. Okay. So how will you get this part here? You will just do 523 minus 18. Okay, so 523 minus 18, what will it give us?
505.
Okay, so that we will have 505. Okay, so what is the total here? 3 plus 18 is 21.
21.
442 plus 545 is what? 949.
947.
Okay, 947. Thank you. Then 445 plus 523.
968.
968. Okay. Now it says calculate the attributable risk for the vaccine. Remember, we said that what the exposure is vaccination. So calculate the attributable risk. So the same way of calculating incidence rate is also the same way of calculating attributable risk. Okay, so the answer to our attributable risk here will be what? Incidence among the exposed. That is what? 3 divided by the total at risk, which is 445. So our attributable risk here will be what? AR will be equal to 3 divided by 445. So what is the answer? 3 divided by 45 is what?
0. 0.0067.
006. Okay, so this is the same thing as if you convert it to percentage by multiplying it by 100, that would be what? 0.6%. Okay,
Okay.
0 point, times 100, that would be 0.6%. So that is the attributable risk. So you can see that it's only 0.6% of death that is attributed to the vaccine. All right. So that means that the rest of the deaths, about 94, about about 99.4% of the deaths among this cohort is attributed to not being vaccinated, that's not receiving the BCG vaccine. Now, the next question is, sorry. Oh my God, what am I doing? This is incidence in the exposed. Oh my God. Sorry. This is the incidence in exposed group. Okay.
I was
Exposed group.
about
Ah,
asking
oh,
because
sorry,
the
sorry.
formula I have
Before.
here is
Yeah.
okay.
So this is incidence in exposed group. Then the next one is incidence in non-exposed group, right? So we still do the same thing. Exposed group. That will be what? 18. Okay. That's 18 over 523, right? So can someone press it for us? 18 over 523. 18 divided by
0.03.
3. What's the answer? 0.
0.034.
0.34.
0.3034.
Yes.
All right. So our attributable risk now will be what? The risk difference between the two, right? So that will be what? 0, 0.
0.006.
Now you need to know that um attributable absolute risk reduction is always positive in nature. So that means that even if you are getting a negative value, is always, that's why it's called absolute. Absolute. That means see that word in mathematics. When you hear the word absolute, it tells you that it's always a positive value. Okay, so in mathematics, there is a symbol that they normally use. My keyboard is not good, so there is a straight line that they normally use to represent absolute risk. So whether you do the difference between the non-exposed and the exposed group. So we have 0.034 minus 0.006. So that will give us what? 34 minus 6 is what? 0.0. 34 minus 6.
Sorry, is it not supposed to be exposed minus or non-exposed? Why are we doing non-exposed minus exposed?
The difference, I said, any way you do it, the answer will always be in positive. So even if you are doing 0.06, there is a symbol that we normally put a straight line to show you that it's absolute. So if you are doing 0.06 minus 0.034, this will give you a negative value, but the answer is a positive value. The answer will always be in positive. So it's actually the absolute risk reduction. So in this sense now, why is a negative value is because it's telling you that it is protective in nature. So whether I do 0.034 minus 0.06 or I do 0.06 minus 0.34, the answer I'm going to get here is always a positive value. That is what I'm trying to emphasize. Okay, so the formula, like you said, is supposed to be exposed group minus non-exposed group. So I'm supposed to put a straight line here to show you that it is what? An absolute value. I'm supposed to put a, I don't know where that symbol is in the keyboard now. There's a straight line that is normally here in this calculation. Something like that. But so to tell you that the difference you are getting is you absolute risk is not a negative sign. There's no negative sign there. It's an absolute figure. I don't know whether I'm clear. So why I'm using the reverse is because is a negative value, and I want a positive value. So, but if you want to use it like this, then you have to put that symbol. Okay, you have to put that symbol to show that your answer is always going to be positive. I don't know
So
whether
we
you are
can,
where I'm
I
going.
understand now. So if we the normal expose minus n expose, and it's
Yes,
supposed to
yes,
give
yes.
us
So
negative.
this is the way
We
it's
should
supposed to
turn it
be.
the other way, right? That's what
Yes,
we
yes.
can. We can do it that way, and there will be no problem.
Okay, well, okay. Let me not say. Just you obey the formula. If you're using this formula now, and you know it's going to give you a negative value, put your sign, your symbol for absolute. It's a straight line. I can't find it in my keyboard. I don't know where it
Okay,
is.
I
I,
understand.
ju-
Go ahead. Go
I
ahead.
just dropped it. I just dropped it on the chat box.
Ah,
Symbol,
okay,
the symbol, you can copy it from there.
okay. Where is it now? The network is, but at least you guys know the symbol I'm talking about, Abi. My
Yeah.
network is just
Yes,
so.
Nathaniel has dropped it. I've seen it.
Oh, okay, all right. So let me just continue because my network is I don't know what's going on. Okay, so can you still see my screen now? Can you guys see the Microsoft
Yes.
the document?
Yes.
All right, so let me just continue. Okay. So what's the difference between these two here?
0.028.
0.028. Okay, and that is which is equal to times it by 100. That will be
2.8.
0.2. Sorry, 0.2.
No, multiply by 100.
That will be 2.8%. Is that right? 1 2,
Mhm.
yeah. So that will be 2.8%. So all right, so you can see here that the so you can see that from this question here, you see that only 2.8% of deaths can be attributed to the vaccine. So you have up to 98 or 90, 97.2%. 97.2% deaths can be attributed to not receiving the BCG vaccine. Okay, so it can be called absolute risk reduction, or it can be called attributable risk. They're the same thing. It's just a difference. All right. Now, if you are told to calculate the relative risk from this question, how are you going to do it? So, how do we calculate our relative risk from this question now? I know it wasn't asked, but it's just a bonus. So, how will you calculate your relative risk since we have all our values here?
Risk in the exposed over
Was
risk in the
divided by
non-exposed.
Yeah,
So
so
that
that
would
would be
be
what?
3.
So that would be 0.006
six.
divided by 0.034. So what's the answer? Equal to. So what's the answer here?
0.176.
Okay, so 0.176. Then times it by 100.
17.6.
So, so 17.6. So risk in the exposed divided by risk in the unexposed. So from here, so you will see that being vaccinated, being vaccinated is the risk of death is 17.6%, but not being vaccinated is associated with a risk of what? 100% minus 17.6%. Okay. So assuming that we are asked to calculate the odds ratio again using the same formula, assuming you are supposed to calculate the odds ratio, what are we going to do?
That would be
3
3
over
over
442.
442
Yes, correct. Go ahead.
divided
3
by
over
18 over
442.
505.
Okay. Then
Right.
divided by 18 over 505, right?
Yep.
So that will give us what?
Okay, hold on a second. 3 divided by, sorry. Okay. 18 over 505. I'm coming up.
What's the answer?
0.1904.
0,
1904, yeah.
0.190. Oh, just 0.19. So that will be what? 19%. Okay. So that would be 19%. Then there's one more thing again that we need to calculate that is commonly asked. That is called number needed to treat.
That's the second question already. Your screen has gone blank. Oh.
I opened a new tab. I don't know what's happening
Okay,
to the
okay, okay.
laptop. Or it's very, very slow this night.
Okay.
Everything is just hanging. The devil doesn't like this our meeting that we're doing today. Oh. See?
We bind and cast.
The devil doesn't have any choice.
So can someone remind us what's the formula for the number needed to treat, please? Just type it in Google, you get the formula. So we can do it at once. What's the formula for number needed to treat?
1 over AR
1
now.
over AR.
NNT.
1 over
okay, so that
AR.
would be 1. Okay, so that would be the inverse. So 1 over the absolute risk reduction is 1 over AR. So that will be what? 1 over 2 points. Hey, what happened?
No, 1 over 0.028.
0.028. Okay, so that will be what?
35.71.
35.71. That is like 38%. You know, it's the whole numbers needed to treat. So
That's
that means
36.
okay, 36. Okay. So how will you interpret it?
That means we need to switch 36% to stop one death.
One harm. Okay. So
One
to
harm.
stop
Okay,
one
sorry.
death. Yeah.
Because
So
we said death now.
yeah. So I think these are all the basic parameters you will need to calculate. Then another thing they can ask is what is the incidence? I think we did that again the last time. What was the incidence of the disease totally for everybody, or the prevalence? Just based on this table, okay? Based on this table here, using this table, incidence is equal to prevalence, just for the sake of this table only, unless they give us the total population. So I'm assuming that all the total population is just 968. Okay, so what's the prevalence here? Assuming that 968 is the total population. No? How will you calculate the prevalence of the disease, of deaths? How will you calculate the incidence of death from TB?
That's the disease over the total. That's 21 over 968.
All right, so 21 over 968. So that would be what? It's 1 over 968 is what in decimal? And anyone with calculator, just press it. My laptop is hanging. I don't want to leave this thing. 21 over 968.
Is this 21? Okay, 21 over 968. 21 divided by 968. Equals to
0.02.
0.21.
0.02. Okay, so times by 100 times, let's say Okay, yeah. So 0.02, that would be what times 100 with 2%, right? Or 2.1%.
0.1.
0.021, right?
Yes.
0.021.
So that, times it by 100, that would be what 2.1%.
2.16.
Okay. Okay. So assuming that you are to express this thing in per 1,000 population, how will you express this prevalence? Assuming that you have to use per 1,000 population.
So that would be 21 over 960 multiplied by 1,000.
Okay,
Then
so
you get
it's still set as 0.021 times 1,000, right?
yeah, yeah.
So how will you interpret it? So if you times it by 1,000, we will have what 21 persons,
21.6.
or that which is approximately 20 or 20, which is approximately 22%. So that's 22 persons per 1,000 population. We die from TB. Okay, in this population now. Okay, so any denominator that they use, you just follow them. Whether it's 1 per 1,000, 100,000, you just multiply it. Okay. So this is just a revision. It's very simple revision of this table. Okay. So let's go to the next question. Let's go to the next question. Okay. So we have already done this one. Okay. So let's go to the next. Okay. So calculate the relative risk of death from TB. We have already done it, right? That's the risk. The risk from that is our RR, which is 17.6%. So next thing is vaccine efficacy. Okay, so the formula for vaccine efficacy is given as, so efficacy is trying to say how effective is the vaccine. Okay, so the formula is our VE, which is vaccine efficacy, is equal to the incidence in the exposed group, sorry, the incidence in the unexposed group, or let's call it the risk in unexposed group. So risk in
Is still under the same table now, Abi?
yes, under the same question. So I'm just trying to interpret this formula here. It's very small. So risk in unexposed minus risk in exposed or in vaccinated. Okay. Okay, then you divide everything by risk in unexposed. So that's the meaning of that formula. So if you cannot cram the formula, you can just cram the words. Risk in unexposed minus risk in exposed, then divided by risk in exposed. Okay, then times 100%, if you like. So I like keeping it simple. So I'll just make use of the decimal points, and then later I can convert it to percentage. So this is the formula to determine how effective the vaccine is. Okay, so using this formula now, the risk in the unexposed minus risk in exposed. So that will be what? Let's see, what's the risk in the unexposed from our previous calculation? So the risk in the exposed, that's the incidence, right? Is
Someone is
0.
saying she can't see anything.
But you can see my screen now, so the person can log out and log in again. It's not from my end. So can you guys see what I'm highlighting now? 0.006. Can Can you guys see my screen? The screen where I'm highlighting now.
Yes.
Yes.
So the incidence, or is also known as the risk too. So the risk in the non-exposed group is 0.034, right? Then the risk or incidence in the exposed group is 0.006. So let me add that one here too for the formula so that everything will be in one place. So we have our vaccine efficacy is equal to the risk in the non-exposed group is what? 0.034.
She says she still cannot see anything. No.
It's not on my own end now.
It's not his fault now. Let her log out and log in.
It's not my
Since
own.
every other person is seeing it.
Check your phone or you can use a different device to log in if that one is not working. So our vaccine efficacy is
It's not my
0.0.
phone.
What's that?
It's not my phone. I've logged out and logged in how many times?
But other people can see now. So what do we do?
I've stepped out now.
You said? Hello? I hope I have not.
Just check if she's at the lobby so you can.
Hello everyone, I'm back. I had to restart it again. So can you guys hear me now?
Yes.
Yes, I can hear you.
So the person that is having issues, can you see my? I've not started sharing the screen anyway. So let me share it again. Okay, so I'm sharing my screen again. So the person that is having issue, can you see my screen now? Can you guys see my screen?
Yes, I can see it.
All right. So who is the person that says
No,
she
let's
cannot
ask
see?
Clarissa. I don't know if she can see it now.
Yeah, just check her on the WhatsApp whether she has. I don't know whether she has left. Okay. So I hope I'm still recording this thing because okay, I'm still recording. All right. So to calculate our vaccine efficacy, it will be 0.034 minus 0.06.
Zero, zero,
Sorry,
six,
0.006
06.
and divided by the unexposed divided by 0.034. Okay, so you can see that when you use numbers, it makes it very, very simple. But when you start cramming all those formulas, if you understand the whole stuff, it's actually simple. So you can see without so much without hundred, I'm just using only the decimal. So can
Excuse me,
someone give us?
please. Did you say? I thought you said the vaccine efficacy is risk in unexposed minus risk in exposed
Yes.
divided by risk in exposed. Is it risk in
No,
unexposed?
no, no. Divided by risk in unexposed, not exposed.
All
Vaccine
right.
efficacy.
All right. Thank you.
Uh, uh. Okay. So what's the
Yes,
answer,
but
please?
can I just say something, please, if you don't mind?
Yes.
So while that formula is okay and it stands, there's a shorter one. Once you get your relative risk, just do one minor relative risk. You've gotten your vaccine.
Okay. Okay. So 1 minus RR will give us our vaccine efficacy, right?
One, yes, once you get that, if you're sure you got that correctly, you can just do one minus that and move on.
Okay. So let me just add that here too, so that just for video sake. So our vaccine efficacy is also 1 minus our
Relative risk.
relative risk, right?
Yep.
Okay. All right. Thank you. So please, what's the answer here? What's the answer for this whole equation? The difference, our absolute risk is 0. So that means 0.028 divided by 0.0334. What's the answer?
I didn't get that. 0.028.
Just press this whole thing in your calculator. What's the answer in decimal?
Okay, that's minus 0.034 minus 0.006 divided by 0.034. 0.823.
So 0. What?
0.823.
Okay, 0.823.
23.
So which is also the same as which is the same thing as 1 minus 0.176, right? I think they're almost the same. They are the same.
1 minus 0.112 what?
Yeah. So if you convert our 0.0823 to percentage, that will be what? 82.3%. Okay. So our vaccine is very, very effective. Our BCG vaccine is very, very effective here. Okay. Is 82.3% effective. Okay. I hope it's clear.
Yes.
I don't know whether is there any other thing again that they will ask here that we have not even done concerning this table. The only thing is calculating your specificity and sensitivity. It's still the same table again, the same pattern, kind of, but a little bit different. Okay, let me see. Is there another big thing here that we have not covered? Odds ratio. We have already done that. Now, you said compare the value for relative risk and give a reason. Wait, it said calculate the odds ratio. Okay, then compare the value with relative risk and give a reason for any difference or similarity. So let's see. Is there any difference in between them? The one we did before. Our odds ratio is 19%, and our relative risk is 17. They are almost the same. So you know that when the outcome is rare, the odds ratio approximates the relative risk. So so if you need to just read around um, advantages and disadvantages of odds ratio and relative risk. So when the outcome is rare, so that's why, like in cohort studies, you know that we said we normally use relative risk, right? So,
Mm.
but sometimes, when the outcome is rare, you can also use odds ratio. So in cohort study, you can actually use both relative risk and odds ratio. So on some circumstances. So I'll leave this one for you to read up. It's just a matter of doing some Google search, and you will see some the reasons why it is so. Okay, so I've not revised that for a long time, but the one I can remember is when the outcome is rare, the two approximate themselves together.
Mhm.
So the outcome here, you can see that the outcome of death here, the relative risk for dying without the vaccine is it very small? Yeah, you can see this is 0 point, this is 3.4%. The risk of dying without the vaccine is very, very small, right? And then if you look at even with the vaccine itself, the risk is not even up to 1%. So that can be the justification, because the outcome of death is very, very small, both in the exposed and the non-exposed group. And that makes the relative risk and the odds ratio to approximate or to become almost the same, right? So that can be a fair justification. Then if you do some Google search, you might get other reasons, but this one is the commonest reason why they might be the same. Okay. Any question? Because we are entering another thing now from here. Any question? Can I continue? Give me feedback.
Yes.
Number
Well,
two,
from
can
this.
someone attempt this one? One of the most common research study design is cohort study. Okay, give two considerations needed when selecting individuals to participate in cohort study. What are the considerations for selecting people that will participate in cohort study? Number one, cohort study is a forward-looking study, right?
Mm.
So the study is looking forward. So it is a forward-looking study. So let me be writing it. So can someone give me, is there any reason why, is there any considerations for cohort study?
Yes, sir.
Tell me now, tell me. Yeah? There is no one answer for all these things. So just, there
The
are many
person,
answers.
Yeah.
the person should be disease free now.
Correct, exactly. So the person should be what? Disease-free. One. What else? Well, let me put it in red marker. Okay, so the person should be disease-free as at the time of starting the experiment. So disease-free, yes. What else?
Should be representative of the whole population.
The sample size.
Sample size should be representative of
Yeah,
the
so you
population.
need a large sample size. So large sample size. Okay, okay, that is representative of the whole population. Okay, what else? Now in this disease free, can you categorize it? I know that they are disease free, but you know that there are two groups now, right? So the first group is exposed to the substance of interest, right? While the other group are what? They are not exposed to the substance of interest. Okay. Then, so what are the other things that you can do? You need to control for bias, for confounding. So, and how do you control for for confounding in this kind of study? Because you are matching the exposed group to the non-exposed group. Okay, so you need to control for confounding. Control for confounding. Okay, so for confounding factors. And how do you control for confounding factors? You control for it by matching. Okay, you match people with similar characteristics. So the population that you want to select, they should be similar in all aspects, apart from the subtypes of interest. Is that clear? So the exposed group, they should be of similar age group, similar ethnicity. You know all those social demographic variables, right? I need feedback. So I'm not talking to myself. You guys know
Yeah,
all those
yeah,
social
yeah,
demographic variables. Good. Apart from
yeah.
the exposure of interest, the population that you are choosing, they should be similar in other parameters. Okay. So for example, if you are doing relationship between um smoking and lung cancer, or so let's say smoking and what now? Smoking and maybe bladder cancer. Okay, and you know that alcohol intake is a risk factor too on its own. Is a confounding variable because it can affect both the outcome and the exposure too. So now, for you to control for confounding, this matching means that you select people that with similar profile in alcohol intake. Okay, so that they will be equally distributed in both groups. So let's say people are taking more than 10 bottles of alcohol, or 10 cups of alcohol in a day. Okay, should be here. Then the same thing too for the non-exposed group, people that are taking the same amount of alcohol. So by doing that, you are controlling for confounding. And how you do this practically is what? Through your what? Inclusion and exclusion criteria. In that time in research, when you see that word inclusion and exclusion criteria, okay, so that is there that you now exclude, or you exclude things. You are trying to uh, remove things that will affect the quality of your research. So ways for controlling for confounding is matching, restriction. So restriction is what? Excluding, when you are excluding people, some persons. Okay, so that cases like, let's say, somebody with a previous family history of cancer, of breast cancer, you see that a positive family history is a confounding factor. Okay, because now you will not know whether the bladder cancer that will occur in future is due to is due to gene, or is due to the smoking. So in order to control for uh, um, in order to control for genetics as a confounding variable, you restrict it. So matching is a way whereby you cannot restrict it, then you allow that variable to be distributed on both groups equally. Okay, so if you are putting 5 males here, you also put 5 females here, assuming that gender is very, very important, and assuming that gender is a variable, you distribute it equally. Okay, so matching, restriction. How else do you control for confounding variable? Now, this last one I want to say now is only seen in intervention studies. That means in randomized controlled trial. So I cannot write it here because this is a core study. But if we move beyond core study, then you talk about randomization. So randomization is also another way of controlling for confounding factors. Okay, and this randomization is done in randomized control trial. So randomized control trial is an example of what? Intervention studies. So let me do a recap of everything I've said now. Okay, so I said generally we have observational studies. I'm doing a recap. I've taught all these things in the video series. They're all there. So observational studies. That means you are not doing anything, you are just observing. So under observational studies, you have cohort study. Okay, so you need to have this in your mind. You have cross study, Then you have case control. Okay. And then you have cross-sectional studies. Okay. So these are all observations. That means you are not intervening, you are not putting any treatment or creating any program. All right. So these are the broad categories. So, but if you go beyond these observational studies, then you enter into the next level, which is called what? Interventional studies. And here, what you have here is what? Your randomized control trial. So that's what you have here, majorly. There are other types, but you don't need it. So what you have here is randomized control trial. Okay. So as I said that if you want to control for bias or confounding variables, you need to do what? Randomization, in addition to matching and restriction. Okay. So this is just the basic things that you need to know. I'm just doing a kind of revision. Okay. So let's continue. Any question? Any question?
No.
Okay. All right. So I hope you guys like it. The way I'm writing it now is very, very clear. That my voice. Okay. So two advantages of core study design. Just use Google and get it now. You get two advantages. All right. So core study design is a forward-looking study. Can anyone tell me any advantage and disadvantage of core study?
Exposure can be measured at several points.
Good. So that's number one. So exposure can be measured at several points. Yes. What else? Just use Google. Just use Google. You will get it. All these are not the main things. Okay. These are not the
Detailed
main.
information on the exposure
What?
can be obtained. Detailed information of exposure can be obtained,
Okay.
and it can be
Information of
collected.
exposure
Detailed
can
information to
be.
wide range of factors can be collected. Of information to factors can be collected.
Can you summarize? I don't know what you said.
Okay, I said
Hello.
for yeah, can you hear me?
What did you say?
Yeah, I said for cohort study, one can collect detailed
Yeah,
information on
I can hear you.
exposure to wide range of factors. Like you can get detailed information on the exposure.
Okay. And that thing again is that multiple outcomes can be measured. Okay. So assuming that you are following up for lung cancer, but the person now have arthritis or cardiovascular disease, so multiple outcomes can also be measured. You understand? In core study and be measured. So that's another advantage too.
Okay.
All right. So any disadvantage of core study? At least now, what's the commonest one? I will not say it. Any disadvantage of core study?
Attrition.
What? Attrition one? Attrition or loss to follow up? They are the same. Okay.
Mhm.
Yeah. So
Since it's a
attrition. That
long-term
means
study, is
what?
has large sample size and is costly.
Exactly. Exactly. So large sample size. Okay. Then it is what? Costly. Okay. It's costly. All right. Please, listen attentively. Can you mute? Who is unmuting? Who is making the mic is making noise? Now look at this one. A retrospective cohort study of 1,700 individuals. All right. To assess the association, like I told you now, always tell me what is the exposure and what is the outcome. Before I even answer this question, the first thing is what is the exposure? That's the first question, and then what is the outcome? So it said association between tamoxifen, and uterine cancer. Okay. Can someone tell me why this thing is? He said in individuals at high risk of cancer. Can someone tell me anything about this word here? Let me know those that can remember what I said before. Can someone tell me anything about this word? Just anything. Does anything come into your mind? How do you think you can control for confounding for individuals with high risk of cancer? Remember, this is the study population. Individuals.
Like you don't know if
Okay.
it is as a result of gene or if it as a result of exposure to some other factors.
Oh, okay. So how will you select your study population to make sure that only individuals with high risk of cancer will come into your study so that you can control for other confounding factors? What are you going to do as an epidemiologist?
You restrict.
You use
Yeah.
what? Questionnaire.
Mm-hmm.
Yeah. So you design a questionnaire to ask them questions. Okay. So you get all the risk of cancer. Okay. And then use a standardized questionnaire, and then you give to your prospective client. They should fill it, and then by the time you analyze the questionnaire based on their responses, you will now know those that are at high risk. Then you can now give them your consent form so that they will now express whether they want to join the study or not. So in this kind of study, so using that questionnaire will now help you to what? Eliminate. So you understand how all these things are done in real life. Okay, so here, what's our exposure here? Our exposure is what? Tamoxifen,
Can
right?
we sorry, hello. So I just got an information now
Yes.
that some people can still not see your screen. I don't know what's happening to
Yay.
you.
Okay, wait,
Can
let me
you
stop
log
sharing
out and
again.
yeah, maybe you should stop sharing and then maybe log
Okay,
out
so
and then
I'll
log
stop
in
sharing
afresh.
now.
Carissa, you too,
I'll
maybe
stop
you can
sharing
just log
now.
out and log in afresh.
Okay, should I? Okay, let me log out. No, let me reshare the screen again.
All right.
Let me know where this is coming from. Okay, I'm sharing entire screen. Okay, wait, let me see. Okay, let me share Microsoft tab, Edge tab. Let me see whether it's from because of I'm sharing entire screen. Okay, now I'm sharing the particular tab I'm using. Can you guys see it now? Can you guys see
Yes.
my
Yes, I can
screen?
see it.
Is everybody seeing it now?
Let me find out.
Is there anybody that cannot see it now? Okay, I'm assuming that we can all see it too. So your silence means that you can see it, Abby. Can I continue?
I think you should continue. I don't know again.
All right. So our exposure here is tamoxifen, and then our outcome here is what? Uterine cancer. So that's my first intake here. Okay. Now, they were divided into two groups. Okay, based on exposed and non-exposed. Now they are giving us our results. Okay, so as you're looking at these results, your eye should be on your 2x2 table. Okay, so remember how our table normally looks like. Okay, so here is they said the chi-square test of association. The chi-square test of association. So if you look at this word, this is a what? A retrospective cohort study. Okay, so what test of association do you use for cohort study? Which one is preferable? Is it odds ratio or relative risk? Which one? Hello?
For cohort study.
Yep.
Uh,
is relative risk now. I've said this many times. Is relative risk is preferable in cohort study, while odds ratio is preferable in what?
Case
Case
control.
control
So
study, right? So this thing you are seeing here, the chi-square test of association, is actually relative risk. It can be relative risk, it can be odds ratio, depending on the type of study. So if you are looking at this SPSS output here, this thing here, this Pearson chi-square, this is your relative risk. This is 0.8 you are seeing here. Okay. So, and that is all you need. You see all these ones here, all these other things here, they are not important. All you can Google them and check their meanings. All these other factors you are seeing here, it doesn't concern us. So this is our 2 by 2 table here. Okay, this one is no disease, and this one is what? Disease, right? Then this one is what? This one is not exposed, and then this one is what? Exposed. The same
Exposed.
principle. Okay.
Mm.
Yeah. So after you have done all the calculation, you will see that your relative risk is 6.48. So we're going to, so let us try and calculate the relative risk. Let's see whether we'll get it. I've not solved this question before now. So, but I'm assuming that should be our relative risk. Okay. So that's based on experience anyway. So can we calculate the relative risk here? What will be our RR? If I have to calculate, what will be our RR here? Let's start with incidence. So incidence in exposed will be what?
113 over 197.
Incidence in exposed group will be what? 113 over what? Over
197.
197, right?
Yep.
Okay. So that will give us what in decimal?
0.573.
0.573. Okay, then incidence in non-exposed will be what?
1000
Incidence in non-exposed.
1000 over 1503.
So 1000 over 1503. And that will give us what?
0.665.
665.
0.665. Okay. Then our relative risk will be what?
Exposed over non-exposed.
Non-exposed. So that will be 0.573 divided by 0.665. So that will be what?
0.861.
0.861. So that will be
Thanks.
20. That will be 86 points.
0.1.
86.1%. So let's calculate what's the odds ratio. What's our odds ratio?
113.
Sorry. Okay. What's our odds? Let's calculate our odds ratio. Okay. So what's our odds ratio?
For the
113
over 84.
over 84. Then divided by
1000
what?
over 1503.
1000 over 503. Okay. So what's the answer in decimal?
503.
Yep.
0.676. 676.
0.67. What?
676.
0.67. Okay, so 0.676.
0.677.
So that will be 67.6%. So comparing the two outcomes that we have our relative risk and we have our odds ratio. So which one do we think that is used in this calculation? Which one do we think that is used in this calculation?
Odds ratio.
I'm also thinking about odds ratio anyway myself. Okay, I'm thinking that the odds ratio was used, but then my equation is, if we're comparing the incidence in the exposed group divided by the incidence in the non-exposed group, and then we're getting a value that is less than 1. So this
Wait.
is 0.861. So this value is very, very low. Wait.
This one
Wait,
is
Sorry, wait.
look at the table. Look
We
at
made
the
a
table
mistake.
again.
We made a mistake. Oh,
Yeah, exactly. That's what I'm saying. Wait,
Ah,
look at the table again.
I'm just wondering. No,
You
you
see,
see,
that
in my brain,
non-uterine cancer comes first. We were supposed to have used
exactly,
the uterine cancer on
exactly.
top.
okay.
Hey.
We are using uterine cancer for disease instead of
Yeah.
For denominator instead
non-disease.
of
Yes.
I still be saying
in
Can
my
wait,
you
brain,
imagine
wait,
how
too.
this table could have?
yes. You see,
Omo.
this exam people,
So,
they are very, very funny. In our brain,
eh,
normally this here is supposed to be disease. This first
yeah, so
column.
they change.
We have
Oh
a
my
So they
God.
time
change it.
mind already.
So as you said, and you can see now, I've already failed this on first attempt too, because I have not solved this personally. I've failed this on first attempt. So please, always, if possible, you can redraw the table. If this one is confusing, redraw the table.
Yeah,
I was
exactly.
now wondering, what happened? Why am I getting strange results? Okay, so incidence in exposed group,
Okay,
exposed
so
disease. So it
let's
should
do
be
it
503,
again.
right? Sorry, exposed group. Exposed group is tamoxifen. So incidence, that's 84 over 197, right?
Mm-hmm.
Is that
Hey,
correct?
good. Yeah.
So we have 84 over 197. So
No, that's not
what's the
that
answer now?
incidence.
Yes. So what 84 over 197? What's the decimal?
54. But
That's
wait,
this one.
sorry, doctor. It looks like it's just me, you, and Clarissa in this class. No other person is contributing.
Yeah, don't worry.
I mean,
Don't
sorry,
worry. Just go
me, you,
ahead.
and Mary.
Sorry,
The video is
I'm
recorded.
I'm here. Oh, I'm here. I'm on transit, but I think I'll settle in shortly.
Oh, okay.
But I'm following every
Okay.
step.
Yeah. Please go
Neka.
ahead. Those that are serious should just watch, follow along, okay?
Clarissa is still
And
saying we
then
should let
moreover,
her in. Doctor, please,
the,
can you check? It's like somebody wants to join. Help us check. Take that, please.
someone should just you can admit somebody. I'm not seeing anybody here. Oh. Can the person join again?
I'm not seeing anybody too.
Maybe she has left. I don't know.
It's showing leaving.
All right, please let's continue. Please anybody that joins, you can admit the person. I'm not the only one that can admit. Okay, so I'm learning from this. You can see I'm learning some tricks. There are some tricks in this exam.
Even me, like, well, after that result, I was like, no, now it's not possible.
Yeah, even me too. I was surprised though. So, what's the decimal? 84 over 197. What will it give us?
Okay, sorry, 84 divided by 197. 0.426. 0.426.
Okay, 0.426. Then
Mhm.
this one, incidence in non-exposed. So incidence, so 503 over 1005. So 503 divided by 1503. What's the
Divided
decimal?
by 1,000, right? No, 1,503. 1,503.
Yeah.
0.335. Should I approximate? 335 approximated.
Okay, 335. Okay, so 0.335. So our relative risk is now 0.426 divided by 0.335. So what's the answer now? Good. You can see that 0.4 is bigger than 0.3, so it will give us a whole number. Because this is where I started having issues with this thing. When it didn't give me a whole number, that's when I know that there's trouble. So tell me, 0.4 divided by 0.3, it should be a whole number. It should be a whole number, sure.
1.271.
So 1 point. These are the kind of scores we normally have in all these kind of. Then odds ratio. Odds ratio now is exposed over non-exposed. So 84 over 113, right? So 84 over 113, then
0.743.
oh, don't worry, just let me finish.
Okay, maybe I should
Then
just press it
divided by
together. Okay.
then divided by 503 over 1000. So 503 over 1000. All right, so tell me the answer.
1.477. 478.
1.477. Okay, so in that case, so we have our odds ratio. So you can see both by relative risk and odds ratio, you see that there's an increased risk for uterine cancer if you're taking tamoxifen. So, but I can't figure out how we arrived at the chi-square anyway. So maybe someone can do a Google search, or in our next meeting, I will do some search again on it, on what it means. But generally, if you search for these variables here, you will see that they are not important in this lecture. They're not important in this question. Okay. So I don't know how they derived 6.483. I don't know. But I was assuming it should be either the odds ratio or relative risk. But then if I look at the significance, I can see, at least I can see that this thing is less than 0.005. 0.01 is less than 0.05, right? So at least I can say that there is that's the risk of the risk of cancer increases with intake of tamoxifen. So the risk of uterine cancer increases with exposure to tamoxifen. Okay, it increases by 27%. Here you can see this is above 1, so it increases by 27%. That's 0.27. Okay, then and then this value is
Please, doctor,
significant.
can you write that underneath it, that the risk of cancer, uterine cancer, please,
Okay,
if it's not too much to ask.
the risk of uterine cancer increases by 27%.
What? Okay.
Among those exposed to tamoxifen compared to those not exposed to tamoxifen. Okay, then this is what? Statistically significant. In brackets, p value is less than 0.05. So this is statistically significant. The p-value is less than 0.05. I think this is what I can say without this table. Okay, so I need to find out what this SPSS output means. I don't know what the 6.8 means. I'm thinking maybe this 6.8, this 6.4 might be the effect size. I don't know. It might be the effect size. So maybe Later, I'll do a Google search to know more about it. That's what I'm suspecting. All right. So what is the question?
No, please go. Please go back to that. No. What you just typed.
Yep.
Okay,
Okay.
P-value is less than.
You can just screenshot it now.
Okay.
But then this okay, don't worry. I want to say something, but don't worry, I won't say it again.
Say
Just
it.
go ahead. Don't worry. No, it's not for you.
Okay. Gloria.
Okay. So
How about the
Hello.
that's
Okay.
yeah,
the
ask your
the
question.
significant figure there from the table is
Here, this one.
0.011.
Yeah, that's the answer. It's less than 0.05 now.
Okay, I'm just thinking
Because
maybe that's the essence of the SPSS
yeah,
aspect there,
I'm
just to
thinking,
guide
yes.
you on. Yeah, I'm just thinking.
Yes. I'm thinking I'm also saying the same thing too. Okay. So but okay, so I think I've already answered the question, even if I didn't mention the chi-square. Did they say that we should describe the chi-square? No, they
If they
didn't. They
use the
said
information. Okay.
describe the key. Okay, so for me, that's the answer. I don't know what all these ones mean. Anyway, I'll find out later. Okay, so let's go to the next one. What's this one again? Name one other statistical procedure that could have been used to test the significance of association between drug status and cancer status. Does anyone have any idea? Name other statistical procedure that could have been used to test the significance of association between drug status and cancer status. I don't have an idea anyway for now, so we'll look at it later. Does anyone have any idea of this one?
Nathaniel, yeah, tell us.
No,
Testing
no,
for statistical. I'm thinking, yeah, chi-square is there.
chi-square is there.
ANOVA. I'm thinking whether you can use ANOVA to compare two groups. ANOVA can compare two or more groups. Okay,
That
then
T-square can
t-test
compare to
can
group. T-test
yeah can
rather.
compare t-test can compare two groups. So, but then let me see. Why I don't want to use t-test here is because the variables are categorical in nature.
Exactly, that's what
You
I'm still
understand?
looking at. Yeah.
So the most preferred test it could be ANOVA. I mean, if what's come to worse,
Chi-square,
but
yeah, chi-square and ANOVA.
ANOVA and chi-square. ANOVA is actually an extension of
Yeah.
chi-square. So that might be my answer for now, assuming that we're not able to get anything. So it's temporary. I don't have the final answer, but for me, chi-square is there. ANOVA is there. These two can go for now. Then I think this phi, I googled this one too. So these two tests, they are measures of effects. They are measures of effect. So I'll just, oh, sorry. Okay, let me, I'm sharing a particular tab, and if I stop sharing it now, I'll have issues. So let me just stop sharing and then share this phi and gamma v so that we can just look at it at once. So just so let me just get this stuff done. Where are we? Drafts. 3 ways to calculate effect size. Let me see. Okay, let me share my screen then. Share screen, entire screen. Okay, so hope you can see my screen. Oh, can you see my screen?
Yes,
Can you see my
finally
email?
I can see it.
I
Yes.
can see.
Oh, thank God! Hallelujah! Hallelujah! Oh. Hey, first in history.
For my first time in this trip.
Okay, where did I write something about karma, something? I don't know where I stored that stuff. But generally, if you type it in Google, let me just type it in Google because I don't know where I saw it in my email anyway. But they are all measures of effect size, and it's simple to interpret. There's nothing hard in it. You just type in phi square, phi
Test.
in statistics also. Phi. Uh, okay, so you can see is a measure of association between two variables. Okay, so let me get the one I saved in my email. I don't know where I saved it again. ROC research. Where is it? I think effect size for chi-square test should be here. I think it should be this one here. Let me check. Yeah, that's it. So I hope you can see my web page or the website I am in now.
It's coming up.
All right. So you can see our file here. You don't need to know how to calculate it. You just to know the interpretation. Okay. So how to interpret it? So you see that there are three ways to measure effect size. We have the phi, the Kramer V, and the odds ratio. Okay. So our phi, they have different categories for phi here. I don't know what's going on with this thing. So how to interpret phi? Okay, so when it is 0.1, it is considered to be a small effect. When it's 0.3, it's a medium effect. And then 0.5 and above is a large effect. So if we apply this formula here, you will see that the effect here is is very, very small. 0. Is less than 0.1 self. So it has a very, very small effect. And then that effect that is very, very small, and then is also is significant, but the effect itself is very, very small. That means the effect of tamoxifen on determining the incidence of uterine cancer is very, very small. So this phi and Kramer V, they are all ways of determining how strong. Remember that the odds ratio will tell us that there is an association, right? The odds ratio and the relative risk, they say that A is associated with B, but they don't tell us how strong the effect is. Okay, so this is how to interpret your chi. When is up to 0.5 is very huge. When is when is less than 0.1 is very, very small. Okay, then you also have your Kramer V too. Kramer V, all these ones I don't know them before. I'm just seeing them for the first time. So Kramer V is interpreted as how do they even say it here? In Kramer V, where where are we? When to use? Okay. I don't know about this Kramer V anyway myself. So let me not say what I want. I don't know how to interpret it. So
Yeah, I think
but-
it's even better because since our lecturer didn't tell us anything, he already made us know that he's not going to ask us what he didn't teach us. So,
okay,
uh, uh,
okay, okay. So then this is your odds ratio as usual. The odds ratio is also a measure of effects. So basically, at least we have the knowledge of an idea on what it is. So let's go to the main one, which is a ROC. So this is where I'll spend more time anyway. Okay, so basically we are done with that. We'll go straight to oh, they even brought out the odds ratio. These people say 1 point. After I stressed myself and calculated it. So we have answered this one, Abi. So the relative risk, so we have already answered it before now. So derived risk, we got 1.478. Let me see. Is it something that we got?
Yes.
1.47. Was it something that we got?
Yes. 147. 1.47.
Okay, okay. 1.4.
That's it.
Relative risk, we got 1.27. Okay. Odds ratio 1.47.
1.47.
Okay, okay. Okay, so I'm thinking maybe they use odds ratio here because it's a retrospective cohort study. You understand? So maybe that's why they prefer to use odds ratio here. So they took some history and also followed them up. So that's retrospective cohort study. Okay, so I don't have PhD in epidemiology, so I don't know it all anyway. So that's my own little disclaimer. I'm still learning too. Okay, so let's look at this one. They said using the confidence interval with a reason, state whether the uterine cancer incidence is significantly affected by the use of the drug.
Where are we?
Oh yeah. Who are those that attempted who watched my video? I explained confidence interval there. They said look at this confidence interval now. See here, the confidence interval is from 1.093 to 1.99. That's the confidence interval for the odds ratio, right? So they are now asking you to comment on this confidence interval. So if you know you have watched my videos, I've explained this thing over and over again in my videos. So can someone make attempts? What can you say about the confidence interval here?
I've not watched the video, so I can't say.
Uh,
Yes, because I was
okay.
even looking at Mike's John's what do you call it, article or PowerPoint, and I
Okay.
just left that part on confidence interval because I really didn't understand. So Motura,
Ah,
No, the reason why
okay.
I'm laughing is because you quickly said you know what. Me, if I never watch them.
Okay. I don't know why people don't like watching videos, but they like live session. They don't like
Ah, if not
to
you,
watch old videos. They like to be stressing somebody to be talking every day, every day. So now to understand the confidence interval, I will just grab forest plots. So let me grab
So
a forest
I
plot.
think if the confidence
Please,
interval excludes
try
one,
and watch my videos.
if the
I don't
confidence
have sense to be
interval
talking every day.
excludes one, then there's a significant effect. What's the question, Seth? This
Yeah,
one
something like
includes
that.
one.
Something like that.
So
It
this one
depends
includes
on
one.
it depends on the hypothesis. Okay. So
Mhm.
sometimes it can be 1, sometimes it can be 0. So, but this is an example of a forest plot. Let it load. Okay, so can someone interpret this forest plot? You just see something like this in exam, and you will not say God forbid.
No, you
They
cannot
didn't
come
teach,
out now. They did not teach
they
us.
didn't teach you. It's not true. They have taught you.
They did not taught us
So
now. Please.
this I'm teaching you now. You see it in exam. Okay, interpret in 1 minute. What's the answer? All right. So this is
No
a
idea.
yeah. So now you can see this this is a meta analysis, and this is how they represent the studies that they use, that they combine together. So this is a diamond. So this diamond is what the summary of all these. Everything here is the measure of effect. It can be either relative risk, it can be odds ratio. So here I'm seeing that this is a relative risk, which is also called risk ratio. Okay. So what I need to look at is the diamond shape here. Okay. So you can see that the overall effect is below 1. So it didn't cross. So from here to here is the confidence interval for this study. Okay.
From where to where? Your cursor is just moving everywhere.
From here to here, this whole line is telling
Okay.
us the confidence interval. You can see this is 0.39 to 1.31. So if you trace this line here down,
Okay.
somewhere here is 0.39. Okay. If you
Okay.
still come here again and trace it down, somewhere here is 1.31. Okay, so the lines are showing the confidence
Yeah.
interval, how wide it is. Okay, and then if you want to get the actual value, you look at the right here to see. So you can see for this one now, the risk ratio is 0.71 for this study now. This GAMSU 1989. The risk ratio that they got the result they got is that their risk ratio is 0.771, and the confidence interval is 0.39 to 1.31 for this particular study, right? Now, but because this study touched this central line here is the line of no effect. So for odds ratio and relative risk, remember whenever it is 1.0, it means what? That there is no association between the exposure and the exposure and the outcome. Okay, so any of the studies that you see here that touches this line here is not significant. So when you say, so whenever you see a study and they are trying to
Soraya,
use,
please, can you let Nathaniel in? I don't know what's
okay, tell him to join now so that I can add him. Tell him to log out and join again so I can add him. I've not seen him here.
He's waiting. He said he's waiting. That
Where
I
will I
have.
see him now?
I did. I let him in.
I think he's in
Okay.
now. I can see he's
Uh,
in.
all right. Okay, so I was saying that the first thing to look at is what? Just look at the line.
I mean,
The
thank you.
line of no effect. So any study that touches this line is not significant. So this one, not significant. This one, not significant. This one is significant. This one is not significant. This one not significant. Not significant. Not significant. Not significant. So you can see that they are all crossing 1. Are you seeing that? They are crossing 1.0. Okay, so now you see that odds ratio and relative risk, they are ratios, right? And the minimum that a ratio can be, not the minimum now, the amount that you say that ratio has no effect is 1 when the denominator and the numerator are equal. So that's why in any study that you are seeing, you are comparing risk ratio or odds ratio. 1.0 is used as the line of no effect. Okay, because it's a ratio, right? So you cannot say 0 now. Can you divide anything and you get 0? Can you say 2 divided by 3 or something and then the answer is be 0? No. So whenever you're talking about risk ratio and odds ratio, is always 1 that we use as the line of no effect. Okay, so now if they ask you to interpret this thing, now you are looking at the summary. This one, you see this one here is subtotal. Okay, so this is a summary of everything that you have seen above here. So this diamond shape, the confidence interval, it didn't touch 1. So that means that this study is what? Significant. Overall, the meta-analysis yielded a significant result. Now, overall, the risk ratio is what? 0.77. That's the pooled risk ratio for all these studies combined is 0.77. And the confidence interval is what? 0.67. That's from here. See that here? 0.67 to 0.89. Okay? Now, this confidence interval is very narrow. Are you seeing that it's very, very narrow, right? So that means it is what? Very precise. If the confidence interval is narrow and it doesn't touch the line of no effect, it means it is statistically significant. So it doesn't contain what? 1.0. Assuming that this thing hits this 1.0, it means that overall all these studies combined, the overall effect is what? Insignificant. But because the confidence interval did not cross the 1.0, it means that overall this meta-analysis is what? Statistically significant. So that is how to interpret your forest plot. So, but there are more details in the video. So after now, go and rewatch the other videos I've done in the past. They are all there on the portal. Okay. Now, there are some studies that you will see that are not odds ratio. That means that it's not odds ratio and the risk ratio that they are using for their measure of effect. Such studies, like they are, let's say you are comparing the mean weight for two groups. That means for those that eat Indomie and those that don't eat Indomie. So you are trying to say, is there a statistical difference between the weight of those that eat Indomie and the weight of those that don't eat Indomie? So that kind of study now is not a study of that you can use a ratio. Rather, you are comparing the difference in mean. Okay, so you will now start hearing something like what the mean difference in birth weight, and you know that that when there is no difference, the difference will be what? Zero, right? So in those kind of studies, this line here, assuming it was a meta-analysis, what you will see where there is one, what you see here is what? Zero. So when you hear anything like mean difference, the mean difference. So the line of no effect for those kind of studies is what? Zero. And once the confidence interval contains zero, it is not significant. Okay. So these are the two most important things you need to learn from this tutorial. Odds ratio and risk ratio, the line of no effect is 1.0. Mean difference, the line of no effect is zero. So when it contains zero, it is not significant for mean difference. Okay, so can we go back to where we were before? I hope you can see my screen. Oh, hello.
Yes, you can still see.
All right, I want to finish this today. Oh. So we have answered almost everything. So he said use the table to state the okay. So the 95% confidence interval is 1.09 to 1.99. So that's the answer. So for this one, our confidence interval is 1.093 to 1.999. Okay, and we can see that it is what? Narrow, okay, and precise, okay, and then does not contain one. It doesn't contain 1.0. So meaning that it is what? Statistically significant. Significant. Okay. So this our result is. So they said now explain. Okay, so use the depth to derive the relative risks. We have already done that. Explain how you derive the value. We have already done that. So from here we can see that the risk of breast cancer is, sorry, let me explain the odds ratio here. Okay, so odds ratio is equal to 1.478. Okay, which is approximately 1.479, which is approximately 1.449. 1.48. So 1.478 is almost the same as 1.48. So that means that the odds, this is how to write it though, the odds of uterine cancer increases by 48% among those exposed to tamoxifen compared to those not exposed to tamoxifen. Okay, so this is how to explain your odds ratio. Okay, then you will now say, therefore, there is a strong association between tamoxifen intake and uterine cancer. So, okay, then you can now bring in our confidence interval. Okay, so here I'll bring in my confidence interval now. So I will now say the confidence interval is, I'll bring in 1.093 to this. It is narrow, precise, and does not contain 1. Okay, that means that it is statistically significant. Okay, then p-value is also less than 0.05. Okay, is less than 0.05. Okay, so also telling us that it is also what? Statistically significant. Okay, and less than 5% of the observations were due to chance. See, so if you write it like this, you get 100, you get 105 over 100. Okay, are we still there? Are we sleeping? Hello,
We're here. We're here.
We're here.
are we tired?
Almost tired, but
I'm
we are
rounding
still
up.
here.
Oh, just okay. Please, I'm rounding up. Oh, because you can always watch this video anytime. I'm bringing in everything together. Okay, so for this question, FEV1, I've not revised it, so I'll revise it and then maybe do the presentation. But you can always Google it. So let me go straight to the next question, which is the one I need to explain very well. So let's go straight to okay. So it said use. So let's go straight to this ROC curve. So if you remember our sensitivity and specificity, okay, our sensitivity and specificity. So I'm going to share my whiteboard now. Please, can you confirm if you can see my whiteboard?
It's coming up.
Okay. Listen
Okay.
attentively. Oh. If you understand what I'm going to say now, you understand ROC curve, all those sensitivity stuffs. Okay. So okay, so this is how the curve is, just something like this. This is your y-axis. Okay, so this is your y-axis, and then oh, I don't know what I'm doing though. I'm not used I don't know what I'm doing though. Hey, what am I drawing? Okay, so this is your x-axis. Oh, Chineke. All right. Okay. Hi. How I take this thing now? Okay. So, okay, so now this is your true positive rate here, TPV. It is also called your sensitivity. Okay, that is what is here on this y-axis. Okay, while on the x-axis, you have your false positive rate. Okay, so your false positive rate is also known as 1 minus specificity. Okay,
Are
they
you
are the
supposed to
same
be
thing.
writing or
What?
you're just talking? Are you writing or you're just talking?
I'm writing. Are you see my screen?
Wait, it's just yeah, exactly. So now I can see what you just wrote because it was
Okay, so that means you can't see beyond the right side. Okay, can you see it now?
yeah.
Okay. Okay, so this is what the graph looks like. Now, the first thing you need to know is to understand how to interpret it. So, if we are moving from on the x-axis, if I'm moving from left to right, that means if I'm moving from here to the right side, it means that the specificity is decreasing, is going down. Okay, if you are moving from left to right, our specificity is decreasing. That is what it means. If you are going
Increasing
like
or
this,
decreasing? Sorry, I didn't get that.
decreasing. Remember that the formula is 1 minus specificity. So if you are going from left to right, your specificity is reducing. If you are going from right to left, your specificity is what? Increasing. Okay. Now, our specificity is defined as the ability of the test to detect a true negative when that person does not have the disease. The ability, the probability of that test detecting a true negative when the person does not have the disease. That is what our specificity. Let me write it just for video's sake. So I said specificity.
I can't see what you're typing anyway. Can we use
Uh,
where we're coming from? This whiteboard, I don't understand it.
So okay, so let me not write, but you understand my English. You can ask me my English and I will explain it. So I said specificity is when the probability of a test to detect a true negative when the person does not have the disease. Okay, so that's the first point. And then I said that on the x-axis, if you are going from left to right, your specificity is decreasing, is reducing. Okay, so those are the two foundations. Now, your sensitivity is defined as the probability of the test to detect a true positive when the person has the disease. That is called your sensitivity. It is also known as what? True positive rate. True positive rate. Okay? Now, I hope my definitions are clear.
Yep.
Sensitivity
True
is the ability to
positive rate
detect a
or true
disease.
positive value.
Yeah, sorry, TPR, not I don't know why I wrote TP is R.
What's TP? Hello, are we there? Can't hear anything again.
Well, yeah, I guess he went mute or something.
I can't hear anything. Gloria, what did you say, please?
I can't hear too. I thought it's everybody.
Oh, okay.
Or maybe we can continue next time. Abi, it's time already, and I don't know.
Abby, should even be rounding off by now. Nathaniel, how far?
Now don't tire.
You never reached to tire.
Now I want to tire this finish. I want to join class.
Go leave only you be that. So good night. Our head off full. Nothing we enter again.
No,
My
no, no, you
guys
want
still
to.
there.
Topic is important. I beg, let's call it a day.
No
Now,
leave
but
only
that
Nat.
ain't today inside you, Abby.
No leave Nat.
Nathaniel, where is
Nat.
saying tire yourself? He just a form agidi.
No, Nat
My
just
mind,
tired.
my mind,
Okay, guys. I can hear you. I can hear you guys. Okay, so we'll continue tomorrow. I will end the meeting now.
Not
Sorry,
tomorrow.
not tomorrow. We'll continue
Next
on
week.
Monday. Is that okay?
But sorry,
Some
you may
of
have
us
to look at the chat. The
some of
Muslims
Yeah, there's
among
some
us
people.
made some complaints, so I don't know what we'll do about that. That they went to
What's the
breakfast.
complaint? I can't see the chat. So can
Okay,
someone
Okay,
tell
they
me
so
went
what's
we
to.
have
going on?
some Muslims amongst us, and they're in their fasting period. So because it takes long now to get dark, and if it doesn't get dark, they can't break. So it was about the time we started that they had to pray and all of those things. So they
Okay. So
couldn't
now,
join.
what will happen is that this meeting is recorded. Okay. So
Yeah.
once I upload the meeting, I'm going to share the link of the
Okay. So
video.
subsequently, then I don't know.
Yes.
we are
Depending on the
Subsequently,
time
suggesting if we
if
can
anyone
we
has
join
edit,
any
them.
we will
question,
schedule. No. So what I'm
the
talking
person
about now,
can.
what about rescheduling the meeting? I
The
don't know
time.
what works for you. The
Okay.
time
Okay. Are you saying that 8 o'clock is too late?
It's
Is
too
that
late for them.
for them now.
okay? Okay. Okay. So what will happen is that the only time I can be free is on Saturdays.
Okay.
Saturdays,
No,
because I work and I come back by 6:40 p.m. By sometime by
can
seven
we still
o'clock.
leave it at this Monday? Is there any time before 8 that is okay for you on Monday?
He said,
Can we still leave the meeting for Mondays? Can you do it anytime earlier before 9? I mean before 8 on Monday.
okay, no, I said I go to work every day, Monday to Friday.
Okay. So
Okay.
what
Yeah.
about Sunday?
And I come back by
What about
7,
Sunday?
6:47 sometimes, depending on the traffic.
On Sundays too?
Understand? So if I come back by that 7, I'll just refresh and then prepare for the
We
meeting.
mean,
So
what
I'm
about
thinking
Sunday?
whether we
Sunday.
can discuss on the time. You guys can agree on a time again when everybody will be around. Okay, then
That's why we are saying, what
we will
about
now do
Sundays?
a refresher. But everybody should watch this one that I've done today. They will do a refresher. If there's any question that you don't understand, you ask me. Then we will do the ROC curve. And then
Is Sunday
I think
okay for you?
what?
Is Sunday okay for you?
Yes, Sunday is okay, but it depends on the time because
If it's
in the
like
morning I go to
issue now,
church,
it's
No,
not.
definitely.
but
We
afternoon
go
I'm
to
okay.
church too. If
Afternoon,
Sunday is
like
okay, what
Night
time?
time now. What time in the night?
It's just it's to accommodate them really because they paid. I mean, they should also benefit from life.
yes. Now, so what I'm saying is that you guys should agree on the group, and then someone can also watch the video, watch the recorded session. It's still the same thing, and then ask questions. If the person have any question, they can ask on the group, and then
No,
we can agree
so
on a time on the WhatsApp. You guys should come up with a time
okay
on the WhatsApp.
for
That's okay
Sunday.
then.
My free period
For
is
Sunday.
Saturdays and Sundays. Those are
That's
the days I
okay.
have free. I'm not
Okay.
free during the week. So if Monday is not working, we can move it away from Monday, and then find a time on Saturday or Sunday and fix the meeting.
All right.
Okay.
Mm-hmm.
All right. So
Thank you.
yeah. How was the audio for today's session?
I was okay. You didn't have internet problem today.
Hallelujah.
Unlike
Okay.
last week.
Oh, okay. Okay. But then, how will you rate your confidence in epidemiology before and now?
It's coming up seriously.
It's
It
coming
has
up.
not
So
reached. It has
the,
not
the,
reached
the
the place where it's supposed to be, but it's coming up.
But it's better than
okay.
when I
So
started personally.
okay. So what is your confidence level over 10 before and then now?
Over 10 before is minus. It's minus something.
Okay. Then now.
Now I don't try to. I can't
Eh?
rate myself, but I know I've tried.
One
Over
over
10.
10.
Over 10. Just over.
Me, 1/10.
Okay. Okay. So please, you guys should agree on the group. Okay, I will look at the times that everybody have agreed on. Okay? Then
Thank
I
you
will
so
see whether
much.
it's just so, but preferably Saturdays and Sundays, preferably. Okay.
Yeah.
All right. Good night.
Thank you. Good
Thank
night.
you.